You know, we're building this future filled with self-driving cars. They're smart, they're supposed to be super safe, but they have one huge problem. They can't talk. Not like we do, with a glance or a nod. So today, we're diving into this really fascinating challenge of our automated future. How do you teach a robot car and a human to have a conversation without ever saying a word?
Okay, so picture this. You're at a crosswalk. A car pulls up, it stops. You automatically look for the driver to get that little nod, right? That wave, that bit of eye contact that says, yeah, I see you, go ahead. But there's nobody there. The car's driving itself. So what do? Do you actually trust it enough to step out into the road?
That tiny moment of hesitation, it's everything. It's this split-second decision that's all about trust and prediction and this silent negotiation that happens. And, getting this interaction right, it's not just about some fancy design. It's about safety, it's about efficiency, and it's about whether we'll ever really feel comfortable sharing our streets with these things. So the first piece of this whole puzzle is the car itself. I mean, if there's no driver to give us a signal, the car has to do it. And engineers are trying everything you can think of, from lights to sounds to, even text displays on the front of the car.
And it turns out the actual words a car displays make a huge difference. Look at this. A clear command like, you can walk? Well, that leaves zero room for doubt. You know what to do. But something ambiguous like, I see you? That just creates confusion. Does that mean it's going to stop? Or does it mean it sees you and expects you to stop? When we're talking about safety, that kind of ambiguity is a really serious problem. Clarity is absolutely king here.
But of course, visual displays only work if you can actually see them. Think about it. At night, in a rainstorm, or for anyone who's visually impaired, sound becomes the main cue. But electric and autonomous cars are famously, almost eerily, quiet. So, what sound should they make? Well, this table really shows the trade-off that designers are facing. A high-frequency tone? Yeah, it's super effective at getting your attention, but it's also incredibly annoying. Intermittent beeps are less annoying, but they're also not as effective. But look at this last one, tire noise. It's highly effective, and it has a really low annoyance level. Why? Because it's a familiar sound. And that makes it a fantastic model for a synthetic ELET that actually works without driving us all crazy. Okay, so we've looked at how the car can talk to us. Now, let's flip the script. How do we talk back? Or maybe more accurately, what signals are we giving the car without even realizing it? To build a car that understands us, researchers first have to understand, well, us. And honestly, this is where things get a little weird. So, what researchers did was they put eye-tracking glasses on people walking through a parking garage. And the assumption they had was pretty simple. In a situation with moving cars, people are going to be looking at the most important things, right? You'd think they'd be watching the approaching car, trying to make eye contact where the driver should be, scanning for threats. I mean, that just makes sense. Except that's not what happened at all. It turns out we spend an absolutely astonishing amount of time looking at the ground. 20% of our visual attention is just on the pavement. Another 20% is on the back of parked cars. And that approaching car, the thing that could actually hit us, it gets less than 9% of our focus. The takeaway here is massive. We are so much more unpredictable than engineers ever assumed. And this just raises a huge question. I mean, if our behavior is this counterintuitive, how on earth can we train an AI to accurately predict what we're going to do next? So, researchers tried to find out. They showed an AI the same situations and basically asked it to decide, cross or not. And you've got to see what happened in this experiment. When an AI model was shown these crossing scenarios one by one, with no memory of what came before it, it actually did great. Its choices lined up really well with what humans did. But here's the crazy part. When the researchers gave that same AI a memory, thinking it would make it smarter, the correlation completely collapses. The AI actually got confused.
This is a perfect example of what went wrong. The AI was shown a clear warning, I'm dangerous. But instead of recognizing the danger, it got stuck on a previous, totally unrelated message it had seen, I'll walk. And it decided, oh, it must be safe to cross. It completely failed to assess the situation right in front of it because it was too focused on the past. Humans, on the other hand, we treat each crossing like a brand new puzzle. All right, so we've established that communication is really hard and that humans are, frankly, unpredictable. But there's another layer to this. Sometimes the car can do everything perfectly right from a technical standpoint, and it still feels completely, totally wrong to us.
This feeling actually has a name. It's called automation surprise.
It's that jolt you feel when the car brakes suddenly for a reason you can't see, or it changes lanes when you weren't expecting it. The action itself might be 100% safe, but because it doesn't match our mental model of what should be happening, it just shatters our trust.
And this feeling of surprise, it's really shaped by three key things. First, observability. Can I see the pedestrian way up ahead that caused the car to slow down? Then there's predictability. Does this car behave like I would? Does it change lanes smoothly to pass a slow driver? And finally, timeliness. Did it give me a moment to understand what was about to happen, or was it just sudden and jarring? Getting these things right is the key to making automation feel comfortable, not just safe.
So far, we've mostly talked about the car communicating to us. But what if we, the pedestrians, the cyclists, what if we could explicitly signal our intentions to the car? This is where the whole thing becomes a true two-way street. Now check out this brilliant concept. It's called Slido. Instead of just using a hand signal that an AV's cameras might miss, a cyclist can simply slide their handlebar grip outwards, and this sends a direct, digital signal to all the autonomous vehicles nearby, saying loud and clear, "Hey, I'm about to turn left." It's this super intuitive physical action that translates directly into unambiguous data.
And here is the best part. It talks back. The system gives the cyclist haptic feedback, basically vibrations in the handlebar. So first, you get a buzz to confirm your signal was sent. Then, another pattern while it's talking to the cars, and finally, a very distinct confirmation buzz when the autonomous vehicles have acknowledged the signal and are actively creating a safe space for you to turn. It's a complete conversational loop. Which brings us right back to our central question. We're building these incredible machines, right? And we're training them on just insane amounts of data to try and understand our messy, unpredictable world. But at the same time, we're creating new ways for us to speak their language, the language of data. So as we move forward, who really has the steeper learning curve? The AI that's trying to master human intuition, or us, learning to live and communicate with the cold, hard logic of the machine?